Have you tried turning it off and on again? This is our next part in our Wi-Fi Lifecycle Series webinar, Troubleshooting and Beyond. We have a really special guest today. He is kind of the wizardry and magic of all things in Wi-Fi, and that is Peter McKenzie. And you know what? This is actually a kind of a cool deal. And welcome to a webinar, Peter. It's great to have you on. And I'm going to pass it over to Tawny. Tawny, why don't you do a little bit more of a welcome for Mr. Peter.
I'm actually going to let Peter introduce himself, because who better to introduce the man than the man? So
right. Great. Well, there. And I guess I am actually your sidekick, Stu. So I just forgot. I guess most of you know that, but and of course my host Tawny and Peter. So take it away, Peter.
Great. Thank you, first of all, for having me on this webinar. It's great to be here with you guys. And for people who don't know me, my name's Peter McKenzie. I'm from the UK, from Yorkshire, which is in northeast of the UK. And I work with a company up here doing wireless design, survey, troubleshooting, consultancy. Been working in the wireless industry for too long, probably 20 plus years. Been, I guess some of the things I really enjoy doing, which we'll get into a little bit more in this webinar, is doing analysis, so protocol analysis and troubleshooting. I'm one of those weird people who loves looking at a trace file because I think they're interesting. So that's me.
Very cool. Well, Peter, we are excited to have you. Peter's been a long time, supporter of Ekahau and us of his. So we're really excited to have you here today. Before we launch into our topic, though, as you guys know, we like in true Ekahau fashion, we have a poll question for you. When troubleshooting, what do you look at first after you have collected your data to diagnose the problem? Do you look at the requirements, the PCAP, spectrum analyzer, channel interference, or I don't look at any of those? Cue my Jeopardy music, Stu.
There we go.
Awesome. Just another couple seconds here as we roll in. I know maybe we should have played the IT crowd music this time.
We should have. Yes, I should have. I'm going to cue that up for the next one, eh?
Yeah. Awesome. All right. Well, let's look at those results, folks. Quite a mixed group. Well, today we are specifically going to look at frame analysis, right? We're gonna talk about that. So number one question people always say, have you tried restarting the device, right? First thing you do, call a help desk. What do they tell you? Have you tried restarting your device? That's not always the case, right? So let's specifically talk about, Peter, some of the challenges within troubleshooting.
Yeah, there's a lot of challenges, I think, in troubleshooting, but I think one of the biggest challenges initially is getting a clear picture of what the problem is, because when you actually troubleshoot a problem, it's normally the problem's normally been passed from person to person to person. Mm-hmm. So maybe the end users have called a help desk and they can't connect potentially, or they're having some issue. And yeah, they've suggested turn it on and off again, and that's still not helped. So it's gone up and got escalated, and then it's got passed from the help desk team to the network team, who have passed it off to the server team, who have then passed it back to the network team. And by the time this thing gets round to maybe you going in as a professional to troubleshoot it and do any sort of analysis, be that protocol spectrum analysis, the problem's sort of gone through Chinese whispers. And you're being told, oh, users can connect to the network and it's happening all the time. And you actually go and talk to the end user. And maybe it's a completely different experience. So getting that end user feedback, I think, is one of the biggest problems with troubleshooting, is just understanding what's going on. And then even once you understand what's going on, as we're talking about this analysis, we're talking about protocol analysis. You've then got two big problems with protocol analysis: is how do I capture the problem data? Because very often people don't capture, that they try and capture the problem happening, but they're not capturing on the right channel when it's happening, or they're not in the right place. So physically getting captured data. And then once you've got the data, the second problem is, okay, now I've got all these 2,000 packets. How do I know what's going on? How do I interpret them to get any sort of feedback? So I think there's some of the issues we face.
Mm-hmm. And I think it's interesting, you know, when you look at troubleshooting and like when the help desk tickets start rolling in, then you know you've got a problem. It's the internet's broken. Okay, well, the internet may not be broken. And then being able to, like, to your point, talk to the end user and really find out what the problem is. Okay, so does it do it when you connect here? What's happening? Do you get connectivity? Is it, you know, when we thinking about the four-way handshake, is that what the problem is, you know, is your web-based application not opening? Are you not able to refresh, you know? So there's a number of things that it can be boiled down to, but there's a lot of ways to be able to look at it. And so while troubleshooting, I think, can be fairly simple in the idea that there are two main symptoms. Yes, we know that there are more symptoms, but there are a lot of things that can cause those problems, right? You know, thinking about the poll question, folks, we're looking at requirements, you know, what is the problem here? The channel interference, airtime utilization. There's a dozen reasons of what it could be. But today, oh, sorry, go ahead, Peter.
No, I was just saying that's right. There's a dozen reasons. But from the user's point of view, it's always the same issue. The Wi-Fi doesn't work.
Right.
You know,
exactly.
It's sort of like the stop blank answer, isn't it? That and I actually have sympathy with the user on that because as far as they're concerned, they connect to the network using Wi-Fi.
Right.
So if there's any part of that network that doesn't work, to them it's just a Wi-Fi. It doesn't work. And I sometimes think as organizations or people delivering a network, we like to say it's not my fault, don't we? So we'll always go, well, it's not the app, so it's not the Wi-Fi. Let's pass it off to some other people. Maybe they're not getting an IP address. We want to pass the bucket. So we pass it to the network guys or the infrastructure team, and maybe we even pass it to the vendor and say it must be the vendor kit, and then they'll go, oh no, it's not our kit. It must be the client driver, and it gets passed to someone else. And we try and I think. Because there's so many points where it could be back-end infrastructure, it could be a server, it could be not enough bandwidth, it could be the RF. The danger is, and I think why a lot of problems don't get fixed, is we just pass the bucket and it goes round and round and round. As long as I can say it's not if my objective in troubleshooting is to say it's not my fault, it's somebody else's. That's often when I feel that sometimes people's default objective in troubleshooting is to prove it's not my bit of the network and pass it to someone else. And I think that's often why problems don't get solved, because we're not willing to look at it holistically. We just want to say, it's not me.
And, you know,
I think that one of the key things that, you know, Peter, you always home in on and I know in your training courses is I observe the problem, right? Observe it. Look at it firsthand. Let's see what it's doing, and then identify, right? So observing is one of the biggest key things, because you know, like you say, everyone likes to point the finger and go around, it's not my problem, it's somebody else's, you know. But when you observe it and see it, right, and I think that's a key metric.
Absolutely. It's very, very key.
And, you know, frame analysis is a challenging thing. That is not an easy concept for wireless engineers. And, you know, looking at the packets, looking at the frames, it can be very challenging. So what we're going to do today is Peter's going to walk us through some examples. So before we do that, let's look at first in a frame analysis, what should we be looking for? So let's talk a little about that, just a couple minutes, and then we'll get into the fun stuff where Peter's going to jump right in and show us some examples of things that we should be looking at and things that what it should look like for us.
Yeah, and I think one of the key things there too, what should I be looking for is you're looking for times when the protocol breaks from the norm. So when is it not doing what it should be doing and it normally is doing? And so that pulls up a really important question, isn't it? Well, what should it be doing? What should it look like? And I think, again, a reason sometimes people have trouble with troubleshooting is they only ever look at packets when there's a problem. So if you only ever capturing data, then you don't know what normal looks like. And I can tell you in a trace file, it's easy to find lots of interesting facts, or what I would call like dead ends. So you follow, oh, that's interesting. Why is it doing this? And you follow it, but it's not actually fixing the problem. It's something that's interesting, maybe even something that's shouldn't really be happening, but actually when everything was working, that was happening and it wasn't causing a problem. So it's if you never look at your network when it's working, you're going to find troubleshooting really difficult, because one of the main parts is, when does it break from the norm? When does it not do what it should be doing?
Mm-hmm. So before we jump into the use cases, we have another poll question. I just realized I've been sharing that the whole time, so apologize, guys. Let's look at our next one. How confident are you that you could use frame analysis to diagnose a problem on an enterprise Wi-Fi network and create a plan of optimization for it? Very confident, somewhat confident. I am not confident at all, but eager to learn. Cue my music, Stu. By the way, sorry that I kept sharing. Next time, somebody just raise your hand and tell me I'm doing that if it keeps sharing. Just another.
I found it. It was the IT crowd.
Awesome. Just another couple seconds on that.
We're out to 5 seconds.
So let's look at these results. Exactly. So this is why we're having Peter talk to us today, is because it's really important for us to be able to, as Wi-Fi professionals, be able to use the tools that are available, because sometimes it's not as simple as, let me fire up my analyzer and look at everything. Sometimes there might be something very complicated that you have to see, and understanding that, this is when, frame analysis comes into play. So I'm going to stop sharing and let Peter take over here for just a minute.
And this is something that we don't usually do, is it, Tony? This is
not.
Actually something special, isn't it? we're handing over the presentations.
I know.
But Peter's the wizard.
This is actually, folks, you're in for a treat today, because Peter is going to show us kind of some magic from his desktop. So let's.
Okay, let me share my screen then.
Yeah. But I think that's one of the things, Peter, I've had the opportunity to sit through your AP class, and that's one of the things that it's just seeing the real world examples, understanding what should it look like. You're, to your point, talking about what the importance of understanding what should the protocol look like is really, really critical to being, to being able to diagnose and manage this troubleshooting process.
Absolutely. Hopefully, I'm going to literally take you through some trace files. So if you've got this and you can full screen it, it's probably a good idea, because there's a lot of small text in a protocol analyzer. So that's something I would say before I begin. But what I wanted to start off by talking about really was, we've already said that one of the main things is to know, what does normal look like? So I thought we'd start by just going through a normal client's connection to a network, because as we've said, a lot of the problems are either I can't connect or we're performance issues. So let's look at the connection route. So first I'm just going to show a normal 802.1x connection to the network, and that's what this trace file is. We've got here captured actually, Joe, in one of my CWAP classes in a lab. That's where this trace file comes from. But you will notice that we're looking at a client, which is I've named here, called iPhone. So we're basically looking at an iPhone's connection to the network. And it all starts with the iPhone trying to discover the access point it would like to connect to. And that's why we see these probe requests and probe response messages. So probe requests coming from the iPhone and probe requests coming back from the APs. And that's just part of the way a client discovers a network. Once it's found an access point it wants to connect to, that's the bit we're going to concentrate in this trace file. And the first thing it does is we'll see these two auth frames where my mouse is here. The first one comes from the iPhone to, we call it access point 2 here. That's the first authentication frame. And if we have a look into that frame, I'm just going to move this up a little bit so we can see in a bit more detail. You'll see the authentication algorithm is something called open system. Open system is the default authentication method that we use in Wi-Fi. In the original standard, there was two authentication methods, one called open system defined and one called shared key. Now, shared key was part of the WAP security suite, which shortly after the standard was published was proved to be broken, and you can now crack a WAP key in under 10 minutes. So we don't use WAP. So it sort of leaves us with open system authentication, which is basically no authentication. You could either use WEP, which confirmed you both had the same WEP key, or use no authentication, open system. And that's what we see mainly used today. So that's what we're seeing. We're seeing a request from the client to do open system authentication, and we're seeing a response come back from the access point. And because it's open system, it will always be successful. So we see the successful code as being successful. It's status code up 0 means it's successful. And it should never fail. If you see open system failure, that tells you there's some bug in the AP. It shouldn't happen because it's no authentication. It should always be successful. Now, obviously, in this example, I said we're doing 802.1xe, which was security mechanisms added later in the standard, and they come after the association stage. So let's look at what happens next. Once we've gone through authentication, the client will then go through association, and we see the client send an association request frame. Association request frame, we can see a little bit of detail in here. Obviously, it's coming from the iPhone going to the AP. We can see the SSID we're trying to connect to. Here it's called CWAP Roam. And we can see all the client's capabilities, what data race they support. We can see a bunch of other information. I'm not going to go through all of this information, but we can see the capabilities of this client. And it's basically going, hey, can I associate to you? These are all my capabilities, AP. I'm a, 2 spatial stream client. I support 802.11ac. And it's basically giving all its capabilities. And in the association response frame, which comes back from the AP to the client, it's again going to have a status code, a little bit like the authentication frame. And this is going to basically say whether the client was successful at associating or not. So in my example here, it's saying successful. If it did say it was a failure, it would give some sort of reason as to why. Maybe the AP's just maxed out on associations and it's got no more. Maybe the client doesn't support required data race that AP has as required. So there could be a number of reasons for failing that association. But what we're looking for is a successful, and then we get an association ID. In this case, it's 3. That's a unique identifier for that client during its lifetime of being associated with its access point.
Peter, can I ask you a real quick question? How do you determine how long you should be gathering the packets? Like, can you just walk us through really quickly first what you do to gather the packets, and then how long we should be so that we can ensure that all of this data is in there when we look at it for analysis?
Yeah, it's a really good question. So I guess it's really all comes back down to defining what the problem is and knowing what the users are struggling with. So if the users is literally, I can't connect to the network, you're probably not going to be capturing for too long. But the place I like to capture is by the client. So I'm normally with the client when I'm doing this capture. Mm-hmm. So I will start my capture going, then I will ask the client to try and connect. When they've had a failure, I will then can stop my capture. Now, if I'm trying to capture a more difficult issue, so a client is, having intermittent problems, maybe they're getting some delayed responses, then I want to be capturing until basically the client has an issue. And I'm going to record the date and timestamp and of when the issues occur. And that's at the point I'm going to stop capturing. Now, sometimes I might wait for 2 or 3 occurrences of the problems. I might be, for example, one I was doing recently was a client that was struggling to, they were getting some delayed responses from a voice picking in a warehouse. So I was following the client around, and I made sure I got at least 3 or 4 instances, all written down the timestamp, and I was capturing all the channels in that warehouse as I was following the client around, doing a multi-channel capture. So sometimes I'm doing that, and I will capture 3 or 4 instances before I stop my capture, because what if I missed a key packet? Other times, once I was capturing a problem in a walk-in freezer that was minus, well, in degrees centigrade, which we use in UK, it was minus 28 degrees. So I was like in its big suit, and I was waiting for a problem to occur, getting more and more cold. And the minute I got one occurrence, I was like, that's great, stop the capture, I'm getting out, let's run away.
I'm getting out.
Peter's like,
But your computer was probably running pretty fast, right? It was probably going, oh, it's great, nice and cold. I don't have to cool myself.
It had a layer of frost on the screen when I came out. It was that cold. It was absolutely. So it depends on the scenario, but at least one instance of the problem, and it comes back to what you were saying, Stu. We've got to observe the problem. I've got to see the problem. If I've not been capturing on the right channel when the problem occurred, there's nothing to look at.
Right? Yeah, you can't see it. And and this is really important that you always, that I know that you point out, is from the APs and the controllers point of view, you don't see this info. And it's there's some things you can see, but not everything, right? And you have to kind of take that holistic approach, like you mentioned, like that third party piece, like, hey, I'm the observer. I'm going to look and see what it is you guys are doing. Right?
And I'm looking at it from the client point of view. If the client's packets for some reason are not getting to the AP, or the client's not seeing the AP, you're not necessarily going to see that from an AP capture. So, the APs, I always say an access point never phones the help desk and say, I'm having a real problem with the Wi-Fi. Never happens. Oh, I've never had an access point phone me up, but maybe as AI gets more intelligence, that might happen. So there was a joke with a vendor that they were going to build in a call Peter button into their software, but I don't think it's happened yet.
I'll be the first.
That would be cool. Yeah, okay. a hidden Easter egg. Okay,
yeah,
so all you manufacturers out there, I'm looking at all of you guys. Put a hidden Easter egg.
But the return of that is the invoice that's automatically generated from Peter.
Right? Yes.
Absolutely. So
please enter in your address first.
Yeah, exactly. And credit card number.
I don't think it's happened yet, but so who phones the help desk? It's the clients, isn't it? And that's the point. So I want to see the network from that client's point of view. I want to see that what's the experience the client's having, because that's what's important to me at the end of the day. So ideally, I want to try and capture by the client and see their experience, because they're the ones experiencing problems. So that's a little bit on why I like to capture by the client, just to get the experience of the person having the issue. And again, I know when they're having an issue because I'm there with the client, so they can say, yep, I had a delay now, or look, no, I can't connect now. Now I know exactly what time they tried, what issue, I saw the issue, and I can correlate that to what I'm seeing in the trace file. So that's really, that really helps if you can do that. Massively helps.
Awesome.
So that's where we get to. That's what this was a captured by the client that we're looking at here as well. Now, after you've successfully associated to an access point, what happens next? Well, if I just look a little bit later down in this trace file, you'll see there's all these EAP requests, EAP responses. And if you know your connection to an AP as taught on maybe CWNA, CWAP, you get authentication, association, 802.1x, four-way handshake. It's what we expect to see. And when I see people teach it, this would be where they would next come to, all these EAP packets. But it's interesting, isn't it? Because when people do that, they miss out. Look, there's all these other frames in between. Look, there's some action frames there, and people often just ignore that. And then there's these funny frames here. Bar. I think it's like some sort of COVID joke for winding up people in the UK, because all our bars and pubs are shut and we can't go. So it's just like, there it is. Just remind you, you can't go to the bar, but you can say bar like a sheep. But anyway, I don't know.
You heard it here first, folks.
Yeah, you heard it here first. My jokes don't get any better. So
right, yeah. But one of the things that always is really cool about when you're looking at the data, and this is one of the, I mean, Tony, I'm sure you agree, this is one of the most deep dives we've done in one of our webinars. But if I can get the audience's attention just for the second, look at that absolute time column. Everything is done by the millisecond. And it's like, look at all of that data that's coming through and the conversation that's happening between the client and the access point at those time intervals. That is amazing. There's so much happening within that second. And it's, I think a lot of folks forget that, there's a lot of things that go on. And if there's something missing, it's got to retransmit itself. So I think it's one thing to point out is that there's a lot of things going on behind the scenes.
Mm-hmm. And when Peter talks about collecting the instances, that doesn't mean like 3 to 5 minutes in every case. Sometimes it's 3 to 5 seconds, you know.
Oh yeah.
And so understanding that it's not a very long process for the collection part.
This whole trace file is 3 minutes 11 seconds long, and we've got 7,264 packets, and we were filtering on one client. So this isn't capturing all the packets on the wireless network even on that channel.
This is just
one client over 3 minutes.
And that's how you can filter on a client for the specific MAC address. You can filter on the channel. You can filter on any number of features within, you know, after you've captured it, you can use, you know, the software to filter what you're specifically wanting to look at.
Yeah, and that's really important, because what I want to do when I'm capturing from a troubleshooting point of view is I actually want to capture everything, because I don't know what I need to look at, do I? And if I filter anything out at capture time, I may have lost it. So if I am following let's say a client round and I'm capturing, say, on 25 gig channels, I may have over even a not very big period of time, I may have millions of Wi-Fi packets literally captured. Some of my captures have, you know, 3-4 million packets in. I don't want to look through all those millions of packets. What I want to do is filter on the client that was having a problem, look at the time period they had the problem on, and start to zoom down. Now, as I'm doing analysis, I may then want to go back and look at something I filtered out. So I'm sat there looking at just that client, and I see a big delay. And I'm going like, well, the AP there should have been a response come back, and it hasn't. And the client's gone to sleep. And then it doesn't wake up for its time. I wonder if the AP during that time is saying, hey, I've got a frame for you in its beacons. Oh, I filtered those out. Let me go back, look at the beacon frames, and let me see what's happening. So sometimes that's why it's good to collect everything, because even when you filter down, there may then be something you filtered out that you want to go back and look at from your investigations.
Awesome.
In here. So yeah, brilliant. And I just think sometimes it's worth, especially if you want to learn Wi-Fi, when you see these, okay, so we know after association, we then do EAP, but it's always worth asking, well, what are these other frames and why are they cropping up at this stage? Before we've done EAP authenticator, why is there an action frame and what is it doing there? Is it normal? I've already said this is a normal trace file, so I can tell you it is, but what is it then? So let's, I thought we'd just have a look at some of these other frames because they're quite interesting. They appear directly after association. And this first action frame, let's take a look. It's coming from the access point to the iPhone. And if we take a look at it, we can see that the action category code is block acknowledgement. So all action frames fall into certain categories as categories of action frames. And they really often tie into which amendment they were introduced into the standard from. But this is a block act, and it comes from, and then the action code is what unique frame within that category is it. So it's an add BA request, add block act request frame. So this is a request frame from the access point to the client saying, can I add a block act? What does that mean? Well, it's saying, can I add or agree with you to use a block acknowledgement policy? So can we agree that we're gonna do block acts with you? Basically, can I send you data and will you use block acts to acknowledge it? That's what the AP is saying. And the policy it's trying to agree is it's immediate block act. So you can get immediate block acts, delayed block acts. We haven't really got too much time to go into all of that on this webinar, but it's saying, I'd like to agree with you that we can use immediate block acts with the data when we send it. So that's the first action frame we see. Then we see the beginning of the 802.1x process, the first EAP request. We'll come back to that because after that is an action frame from the client to the AP. And it's actually a response. So this is called a add BA, add block act response. And it's basically the client coming back saying, yeah, I agree to an immediate block act policy. So that's brilliant. They've agreed that in one direction, but basically the client has agreed to send acknowledged data using blockACKs in that direction. The AP can send multiple data frames and the client will acknowledge it. And then we get a bar. This is our bar with an R. This is reminding me about going to a bar. I've just scrolled up. My mouse didn't do what I was trying to do. Let me just go back to our bar frame and we'll have a look at what that means. Well, this is a blockACK request. That's what BAR means, blockACK request. And let's have a look at what it's doing in it. Sorry about, there we go. We're back on this blockACK. And you'll see it says, blockACK request, it's requesting a blockACK, starting sequence number is 1. And it's 1 because basically it's not sent any data yet. So it's saying, we've not seen any data frame saying, but it's saying, can you blockACK nothing? So it's basically just a little test. Okay. What should be on this blockACK request? I do apologize. It says the access point, send it to the iPhone saying, blockACK request. You've said you can send a blockACK. I'm testing you now. I don't believe you. I know you've agreed, but let me just test and see if you really can do it.
It's that darn trust thing.
Yeah, I don't really trust it. So we'll just do a bit of a test. So here's the blockACK.
You're just really saying, is the bar open or not, right?
Is the bar open?
I don't believe you.
Yeah, basically. And the client comes back and goes, yep, I told you so. Here's a blockACK starting at sequence number 1. I've got nothing to acknowledge because you've not sent any data, but here's a blockACK request. So it's just confirming that policy they agreed they can now do. And then following that, it's really interesting. The client then sends a blockACK request to the AP and said, okay, I've agreed to send blockACKs to you. Will you agree to send them to me? And then we get another set of action frames. Now they're agreeing it in the other direction. So the access point agrees. And just like the AP didn't trust the client doesn't trust the AP. So it says, are you sure? Let me just test it out and make sure you can do it. And it sends a blockACK request and it gets a blockACK response.
And that's one of the big things when you're looking at packets and you're looking at the frames is the reciprocity of how it goes back and forth. Can you? Yes. I'm going to test. Can you? Yes. And you'll see, as you can see here in the trace file, you can see the reciprocity back and forth. And that's part of what you're looking for.
Yeah. And that's kind of what you're looking for. And that's normal. What we just look for, that happens normally. And the nice thing about nursing is it can happen the minute you've associated. So we've not been for 802.1x. We can't send data frames yet, but this is a MAC layer function. It's all happening at the MAC. We're not trying to pass data on the network. So while we're doing this 802.1x process, all of this is going on as well, simultaneously. So it gets on with that job, even though it's still going through its 802.1x. And that's what I wanted people to see, because you often don't spot that going on. Or if you do, you're just like, I don't really understand these frames, so we'll ignore them.
Well, and I think that's important for us because, we don't always know. And as we've shown, frame analysis is challenging and not everybody knows how to do it. Understanding that, folks might not know exactly what to look for. And so that really is helpful to understand what it should be looking like and understanding that it's happening simultaneously in that process.
Absolutely. So
here's what it should look like normally, but here's what it does look like when it's not, right?
Right. Yeah.
So then we get the 802.1x process, and I'll quickly go through this because I'm going to show you a couple where it doesn't work. This one's working. Now, 2 ways to start an 802.1x process. Either the client can initiate it with something called an EPOL start frame, where the client just basically says, can we start doing EAP? But that's optional. Or the AP can start it by just sending an EAP request. Now, in this case, the AP is sending the first EAP request packet. And if we have a look at this packet, it's really simple to understand. If you look at the decode of it, and we can see, my mouse keeps jumping about. I do apologize for that. It's really easy to understand. It's a request, and it's a request of type identity. So it's a request for identity. And it's basically saying, who are you to the client? What's your identity? If you want to connect to this network, have you got the right credentials to connect? So it's basically almost saying, what's your username, if you like. That's the question coming back. And then we'll see in the response coming back from the client. Now, in EAP, you always get requests go AP to client and responses go client to AP. So that's always tells you the direction. So then we get an EAP response. And the EAP response says it's a response to the identity correction. And here's the data. My username is test1. Not very imaginative by me, but that was a username I set up, test1. So there's a response, and then we get a little bit of time goes by, not too much, and we get another EAP request. Now, this request, it's important to understand what happens when this response for identity comes back to the AP. At that point, the access point is going to contact the Radiant server and send that request on, because the AP is a bit like a man in the middle in an EAP exchange. It does the first bit, give me your, who are you? Okay, you're Peter, or you're user one or task one. Now it's going to say, hey, Radiant server, this guy wants to connect. Will you allow him to? So it just passes it on to the Radiant server. The Radiant server will then respond, and whatever it responds with, the access point will just pass on in an EAP request. So the next EAP request is actually coming from the Radiant server, but just via the AP. And we can see in this one, in this next EAP request, it says EAP TLS start, which is basically the Radiant server saying, can I start an EAP TLS process? That's what's going on here. And then we get an EAP response. And the EAP response coming back from the client is NAC. Non-acknowledgement, negative acknowledgement, depending on how you interpret it, but it's basically saying no. So the Radiant server said, can we do EAP TLS? And the client's come back and gone, no. Okay. Now, there's actually a suggested auth type here, and it's a code. That's actually the code for PEEP. Not all protocol analyzers decode that. So in the next request that comes back from the Radiant server, we see it says, okay, how about PEEP? Can we do PEEP? And this time the client says, I can do PEEP. This is my client hello message. Now inside this message, it says, these are all the different cipher streets I can do EAP with. And there's quite a long list with the iPhone. So we're looking at more, but you've got things like, you know, TLS with AEX, 128 bits, CBC share, and it's all the different cipher streets the iPhone supports.
And understanding one of the reasons why you might get a negative response is because the client is not physically capable of doing that type of authentication, or, you know, and so it's understanding what are the specs and the capabilities of the client. And so the client it's going to run down a list that, you know, the AP, can you do this? No. Okay. How about this one? Yes, I can do that one, or no, I can't. And then it's going to go down to the next list to keep going until it finds one that the client supports. Yeah,
and it's important that whatever the client supported, whichever EAP type you've configured the client to support, that's also supported by the Radiant server, because the Radiant server will literally just go down its list and try them. So it sends its client hello, and then we get an EAP request. Now notice this is a bit of a big size packet, because this is comes from the server. Includes the server hello, and notice it's picked one up the cipher tree supported by the clients. So it's just picked one and said, okay, we'll do this one. Out of the list you've offered me, I'm going to choose this one. And then it's interesting. The reason it's big is this is where the authentication server, the Radiant server, sends its server-side certificate. So it's a large file because it includes the server certificate in here. And that's what we're seeing decoded. And we'll get a response, basically an acknowledgement for receiving that. And then eventually, once that certificate has been validated by the client, which happens in its client key exchange cipher packet, it then establishes an TLS encrypted tunnel between the Radiant server and the client. We call it a tunnel deep type PEEP. And the rest of these frames, we'll look at a couple of them, but you're not going to see a lot because it is now encrypted. You'll see that there's going to be encrypted data elements in using this TLS tunnel. So all the data that we'd normally see is all encrypted in this TLS area. And what it's doing is a second EAP exchange with the username, password information, but it's doing it in an encrypted tunnel. And that protects it from a man-in-the-middle attack. And what we should eventually see, if that authentication goes well, is a EAP success packet. So the success packets come back from the Radiant server saying, yes, you've successfully been through authentication. You are now authenticated on the network. And that is going to be followed by what we call a four-way handshake, which are these 4 ePOL key packets. The client is connected, and they can now send encrypted data. So that's what we have going on in that process. And you'll also notice as we get to this data, we start getting block acknowledgements and block requests because we've previously set up block acknowledgement capabilities as well. So that's what a normal sort of connection should look like. Shall we quickly look at some ones where that process fails?
Yes. I like looking at the bad examples because then I know where
to look, right?
It'd
be cool to let it's because I think the audience really is, you want to really understand is, where is it going bad? Where do we see that? And what should we be seeing when we see something bad? Because that's what we're always looking for, right? Is deciphering the good from the not so good, and you're trying to kind of understand, hey, did we say hello, or hello, Tawny? But she's not going to say hello back, right? So,
there's a wall here.
There's a wall, right? Yeah.
So this is one that's actually been captured by an AP, just capturing the authentication frames, just as a different look at data. But we're going to mainly look at this protocol column anyway, and we can see authentication frames. We know that's the beginning of the client's authentication, an association request and response system. It's a reassociation, so it's like a row. And we see the EAP request. But remember I said there was another frame that could start it, which was an ePOL start. The client goes, oh, hang on a minute. No, I want to start the EAP process. So ePOL start. So we see the first request from identity. Then the client goes, no, I'm starting the process. Can I start EAP? Which is silly because the AP's already started it, but clients do that sometimes. And then we see the AP goes, oh, okay then. Can you give me your identity? And just sends a request again. The client, having received 2 EAP requests, sends 2 EAP responses. You can see this client's obviously quite clever, not. And it sends one response, here's my identity. Oh, and as you asked me twice, I'll send you my identity again, user 1. That's not the main thing we're looking at. It's just a funny aside in its trace file, but it's the sort of thing you'll see. Then what happens? Well, what should happen at that point? The AP should send that request up to the Radiant server, and the Radiant server is going to respond. I'm just going to stand on another field here. You can see the absolute time, but this is another field called delta time, which tells me the time between packets. Because we'll see the very next frame is an ePOL start frame. Can we start the EAP process? But notice that's after 23 seconds of nothing.
Yeah.
So
yeah, I saw that sitting there when you went to 1359, 27 to 50, and I'm glad you pointed that out because that's a huge, right?
It's a massive difference. So what's happened here is nothing's come back from the Radiant server. We know that's what should happen. Maybe the AP's never talked to the Radiant server. Maybe it has, but nothing's come back. But we've just not had a response. And then 26 seconds later, the client goes, can we start the EAP process? And we get another EAP response and request for identity. And eventually the AP goes, well, this isn't going anywhere. I'm going to kick you off. And we get a D off. And then it starts again, open system of, and we can look through this, but it literally just does the same thing again. And it gets to that point when the Radiant server should be connected and we never get a response. So this is an example of why maybe then we'd want to have a wired capture going as well, because I want to know, is the AP talking to the Radiant server? And if it is the Radiant server responding? In this particular example, the Radiant server was not responding at all. And it's because the AP hadn't been configured as an authenticator in that Radiant server. So it was just ignoring the request from the AP. But again, if we know what normal is, we know what should happen to this response, and we look at this time, we can see that at least where to look next. we know something's breaking down between the communication between the AP and the radiate server, and it's given us that indication. Because we know what it should be doing, we can see where it's breaking that norm. So that's one where it failed to respond. I've got one more I just thought I'd quickly show you, where we actually get a bit more through that process. So again, we've got 2 authentication frames, association requests and response, some action frames, as we talked about, but we see this E process beginning. Now in this one, we see our request for an identity, and we see a response. This time it uses user 1. And it actually, this time, first thing it does is the radius server goes, how about MD5 challenge? Well, you should never do that over Wi-Fi because it's an untunneled type and it's quite bad. So again, we get a knack back from the client I'm quite pleased about. And eventually it says, okay, do you want to do PEEP? And the client responds with a hello, everything we'd expect. Now, I want to show you something a little bit different from the last one though, in this one. Here's the server hello when it sends its certificate. And the bit when the client basically goes, yep, I've got that, let's move on, is right down here. So what happens between this certificate packet and the next one? Well, notice all the big frame sizes coming from the radiate server. This is actually all the certificate. This radiate server had a really big certificate and it couldn't send it in one frame because of the maximum frame size. So it's just sending it in multiple frames. And you see that with stronger security now on modern day radiate servers, they tend to have larger certificate sizes and it tends to take several frames for it to send the entire certificate. So
it's a normal event is to see something like this when you have those large. Okay, that's good to know, right? That's good to know because most people would think, oh, is it retransmit? What is it doing?
Yeah. And it's actually just sending a very large certificate. And then that's what we're seeing there. It's just over several frames. And then, so this seems to go normally. But what we see here, remember we saw an EAP success in the first example. In this one, we see an EAP failure. So this is a response from the radiate server, but it's saying you failed your authentication. So the user didn't go through successful EAP authentication. It's been successful in the fact that the protocols worked, but the credentials the client supplied were wrong. So maybe they typed in the wrong password. Very likely, and it's gone, nope, you don't have the right credentials, you can't connect. And because we get an EAP failure, the next thing the AP does is de-authenticate the client. So here, it just looks like the clients use the wrong credentials. They've maybe got the wrong password and they're typing a password wrong. So we can see that from this de-authentication that we get. So that's just a little, a couple of examples of just looking at a client's connection and places it may or it may not go wrong. I'll stop sharing at that point.
Wow, that is an amazing amount of information today, Peter. I mean, you've given us a lot of food for thought, and I think it's and I'm sure Tanya would agree as well. It's not just looking at is it connecting? Is it something on the back end? Is it that little bit of information like authentication? Like, is it not getting the certificate right? Is it the certificate too large? I mean, obviously, there's security reasons why it needs to be that way, but what does that look like, right? There are many different factors, and I think you've highlighted a lot of that, and there's a lot more for another webinar. I would agree. Would you agree, Tony?
That's why boot camps are 3-4 days.
Right. Yes. Yeah. You've just seen a snippet of one of Peter's magical, boot camps, and I know both of us. We both actually have sat Peter's boot camps, and I almost want to go back again and to sit it again because there's so much information. Right.
And I think that's the point. And so, folks, we understand that this is a complicated issue and there are a lot of questions and a lot of specific, one-off things, without offering, the button in your software that says, send it to Peter. Please feel free to reach out and ask him a question on Twitter. Peter is fantastic about that. I'm volunteering Peter to do that. But Peter, as we wrap up, what are just final thoughts? But before we get to final thoughts, how do folks, if they're not sure what to do, what do you suggest for them to start? Like, I think I need to do a PCAP. What do you suggest? What's the start process for folks?
So as a start process, I would say is get some kit you can capture packets on. And the Ekahau Sidekick is a great example of a tool. And the thing I love about a Sidekick is it's got 2 radios. So you can actually capture 2 channels at the same time. So if you were capturing a roaming event, but just capture packets. And, that's how I learned. When I started out, I had this tool and I could capture packets. I was fascinated. So I captured packets everywhere I go. I'm set in a hotel room. Let me just capture some packets. I'm set in an airport. Obviously, we can't do that nowadays, but you set in an airport, capture some packets. I've got some time. At home, capture your home Wi-Fi traffic and then go through them a little bit like I did and say, can I explain or do I understand each packet? And when you get to something you don't understand, do some research. Do a bit of Googling or get the CWAP book and try and learn what are those packets until you understand it, and then carry on down the trace file. And by just looking at lots and lots of captures, this is capturing what normal is, capturing when things work on your home network, making sure you understand it. And if you get to frames, you go, I don't understand what that is, that's the time to do some research. What are all these null function frames I'm seeing in my captures? What are all these CTX frames? Whatever it is you see, try and investigate it till you understand it. And it's honestly, that is the best way of learning. To learn, and I would say, even if you just want to understand 802.11 protocol more, not even how to do protocol analysis, do protocol analysis as a learning tool.
One of the things that really helped me as I was going through it is I created flowcharts. This is what the process should look like. And so it goes from here to here. Where could it possibly break down? And that's kind of how I went through my, when I was studying.
No, I agree. And flowcharts are great because protocol is logical. It's like state machines. It does things in a logical way. So if you've got a logical mind, and one thing I very much like about protocol, people often get worried about, say, taking the CWAP exam. They get the hardest exam, but it's a little bit like maths. And I like it because it's right or wrong. It's logical. It goes, it does this, it does this. It doesn't, maybe sometimes, it's not like wireless design where everyone's got a different opinion on how it should work and what stage you should do first and when you should do it. It's factual and logical. So it's quite good to learn, and doing flowcharts or any sort of logical flow. Yeah, right. A great way of learning and remembering it.
Yeah. Peter, before we get to final thoughts, Stu, what are any final thoughts for you on frame analysis, looking at packets, looking at the protocol analyzer?
Absolutely. And I think it's don't be afraid to look at it. I mean, obviously today's information it could be somewhat overwhelming for some users, but it really isn't. And I think it's talking as reading another language in a way, and just kind of observing what the process flow is on how a client talks to an access point. And then once you kind of grasp that, you'll kind of like, oh, wow, this is actually kind of cool. This is what's actually involved in how the driver works on this device. That's when you can kind of go and look, oh, the driver's not working, or here's observing that problem as I'm not authenticating because I'm just too far away, right? And it may not be, it may be, look, the AP's right, the design is right, the signal is right, but ultimately it might be a client problem. And so it's always good to kind of be aware of, there's that extra level of extra level of troubleshooting that you would go into beyond the basic designs and interference and whatnot.
Yeah, there's a whole other world, because it's, channel interference is a huge problem, but the authentication and the communication via frame, looking at the protocol,
Absolutely,
is also really, really critical in that process of understanding. And that can break down and does break down. And so you've got to be able to look at all of the features. I think that's why troubleshooting people, and myself included, get intimidated by it, because there are so many things that could go wrong. To our point when we were talking about it, the challenge is it could be 100 things that are causing one of two very common symptoms: the slow connectivity or no connectivity, but it could be an astronomical number of things that can go wrong in that process, because it is a complicated process.
Absolutely.
So Peter, final thoughts for you about frame analysis and in general.
Yeah, I think, it's not easy. So I would say, but it's something worth learning, because the amount of times it makes, if you've got that skill that you can take a packet capture and analyze it, I feel it's a bit like a get out of jail free card if you play Monopoly. You've got that tool and skill you can apply to any situation. Something's not working. Let me just capture the packets, find out why. And it's an invaluable skill. So I'd say don't be intimidated by it. Just get into it and do it. You've got to jump in with both feet, and when you start looking at trace files, think through it as a conversation. So filter down to just one conversation. Look at that, and maybe you need to look at another conversation. So you're going to refilter to another conversation. But as you look at it, take it conversation by conversation, and think for each packet, well, what is the access point saying to the client at this point? What's the client saying back in return? Or what's the core message that's being sent, and what is the response? And as you start to do that, you just break it down, and it becomes much more simple to understand.
Awesome. Well, thank you, Peter. We are right at the top of the hour almost. Everybody, thank you for joining us today. And Peter, a huge thank you to you for spending time explaining a complicated topic, making it a little easier for us. So thank you so much for joining us. And with that,
thank you for having me.
Yeah, I'm Tawny,
and thank you for joining.
Stu and Peter, and that's all we have, folks.